All right, part 2 video from Inequalities, Chapter 8, Section 5. I sincerely hope that you watched part 1. If you didn't, check it out. It does show you all the steps involved in solving these guys. So, step 1, if you didn't already know, is to set what's inside the square root greater than or equal to 0. So, let me do that. 2q plus 1, that's what's inside the square root. Got to be greater than or equal to 0. You don't get a choice. Subtracting 1, divide by 2. So q has to be bigger than or equal to negative half. Now, sometimes in math there is good news, but the good news is usually followed with some quirky thing that you got to remember. So here comes the quirky thing that you got to remember. Solve the original problem with step 2. And I want to solve the original problem like I normally would. So I normally would subtract 6 from both sides first. Well, that's what I'm going to do. But if I subtract 6, I get negative 4. And we talked about this in the equation solving part. If this was an equation, so it's impossible for a square root to equal a negative number. There's no plus minus symbol in front of that square root. If I check it, it's not going to work. Well, with greater thans and less than, you got to be careful. So is it possible for a square root to be bigger than a negative number? Well, yeah, because when you take a square root, I get a positive number. Positive numbers are bigger than negative numbers. But this guy says less than. So if this guy is supposed to end up being positive, and remember there's no plus minus symbol out there, so it's implied that it's going to be positive, how is it ever going to be less than a negative number, a negative 4? It's not going to happen. So that would, for all intent and purposes, be no solution. Now here's what makes these kind of weird. There were two parts to this answer. Q is greater than or equal to negative 1/2 and whatever happens in the other one. So I'm just going to follow the procedure. Procedure 1 was to set the 2q plus 1 greater than or equal to 0 and solve. I did that. Part 2 was to solve it like normal. I did that. And part 3 was to do a number line. Now this would be completely unnecessary, but I'm going to do it anyway. The only number I ended up with is a negative 1/2. Right. Well, I'm supposed to graph both of them. And I know this is a drawn out process to get to what's going to end up being sort of an obvious answer, but bear with me. So greater than or equal to, shade to the right. Well, the other one was no solution. And no solution, I can't graph no solution. But the point of the number line is this. If I'm supposed to see where the two answers overlap, they don't overlap. I have the top line. I don't have any bottom line at all. So the problem is impossible. So the reason I went through that was just to point out if you did have the opposite version of this answer. So in other words, if this guy had ended up being all real numbers instead, well, how would you graph all real numbers? All real numbers would be just graph everything. And now they do overlap somewhere. So it is important to go ahead and follow through and do that step number 3, even though that guy ended up being no solution. So tricky one. Now 5, not as tricky, but definitely lengthy. So you might be saying to yourself for 5, well, this is going to be easy. All I have to do is square everything. That's gone. That's gone. And I get a 25 over there. And I wish that were the case, guys. But if you're going to do something to one side of an equation or inequality, you have to do the same thing to the other side. How many squareds do I have written on the left side? I see 2. How many do I have on the right side? I see 1. That's illegal. I'm not doing the same thing to both sides. So unfortunately, the squared's got to go. I can't do that. But I can do this. I can square the entire side at one time. And that would work. However, if I do that, that guy right there is going to become a big old nasty FOIL problem. So the good news is you can make it a little easier on yourself. The bad news is you're going to have to do a FOIL problem no matter what. So here's what I'm going to do. I'm going to keep this guy over here on the left. And I'm going to move the square root of d over to the right. So if I square both sides now, at least over here I get a FOIL problem that's got a little less stuff going on. All right, well, square root disappears, pops out of there. Square the other side. And here's this one thing that you guys like to forget over and over again. It drives me insane. Squaring a set of parentheses means write it down twice and do a FOIL problem. Okay, a little tough for FOIL problem. We can do it. First one times first one. Multiply the outside 2, or the 5 times the square root of d. Multiply the inside 2, or the 5 times the square root of d. And let's a little bit of time here. Last one times last one. A negative times a negative is a positive. Square root of d times the square root of d. Well, that's like having a pair of them. A pair of them just makes it pop out of there. So that gives me just a d. So now I got to clean some stuff up here. Still got my d plus 5. I'm going to write the d first, no particular reason, but I can combine that guy and that guy. Negative 5 of something and negative 5 of something would make negative 10 of the same something. All right, the ultimate goal is to get the d on one side, so that's why I wrote that d first. Eventually, I'm going to have to move these guys over to the same side, and conveniently, they cancel out. So I'm getting closer. Got to move the 25 at some point. Moved them. All right, well, remember this little trick. I can always change signs. Like I don't like these negatives, I can change them. But here's what does make that tricky. If you were going to pull that trick with an inequality, then I got to literally change the signs. So I got to change this to that. Divide both sides by 10. Quite a few steps, huh? So I got to get rid of the square root. I got to square both sides. And I'm going to flip this guy around for shading purposes. So there's the answer to the original problem. But you know what? We never set what was inside the square roots greater than or equal to 0. And I got to do that. So let me scroll up. Whoop, I can't quite do that. So I'm going to do this. Let's make ourselves a little extra area over here. And guess what? There were 2 square roots. So one of the square roots had a d plus 5. But as we talked about earlier, that would have to be greater than or equal to 0. And there was yet another square root that just said d. And that means that square root would have to be greater than or equal to 0. So this guy's already done. He's already solved. So there's one part of my answer. I had to subtract 5 here. So this guy ends up with 3 parts to it. Now look at the original problem. Here's why. There was one square root that had a d. So that guy has to be greater than or equal to 0. I'm going to make one answer. There's another square root. That guy has to be bigger than or equal to 0. There's a second answer. And the directions is to solve the original problem. There's a third answer. So how do we put this all together? We do a number line. So my 3 answers. I got a negative 5. I got a 0. And I got a 4. All right, here we go. I'm going to do this guy first for no particular reason. I see an equal to sign, which means I go close circle. I see a greater than, which means I shade to the right. I'm going to do this guy next. I see a greater than or equal to, which means close circle. I see a greater than, which means shade to the right. The third one. I see an open circle for that one. But I see a less than, so I shade to the left. Well, where do all 3 lines overlap? They all overlap between the 0 and the 4. So check it out down here, negative 5, 1 line, no way. Between negative 5 and 0, I got 1 line up top, 1 line on the bottom. I don't have all 3. Clear up here at the top, I got the top line, I got the blue line, but I don't have all 3. So here's the only place where all 3 overlap. So my 4 had an open circle. I'm just transferring that up. When I originally did my shade, the 0 had a closed circle. I'm transferring that up. All right, let me go ahead and scroll up here. So now that we got all 3 of our answers, we just got to finalize it with interval notation. So how do we write a shade that's in between? Well, we say the shade starts at 0, and it has a bracket because it's got a closed-in circle. The shade ends at 4. It gets a parenthesis because it doesn't have a closed-in circle. And that is a big old long nasty FOIL problem to come up with that guy. But just keep this in mind. There were 2 square roots, which means 2 ands, or 2 additional parts, and the original problem makes a third answer. All right, guys, that's the conclusion of 8.5 inequalities. Thank you for watching.